Picture two identical cups of water, side by side, one boiling hot, one at room temperature. Put them in the same freezer at the same time. Common sense says the cooler one freezes first. It has less distance to travel. Except sometimes it doesn't. Sometimes the hot cup freezes first, and physicists still can't fully agree on why. This is the Mpemba effect, and the story of how it got its name starts in a school kitchen in Tanzania in 1963. A student named Mpemba was making ice cream with his class. Short on freezer space, he skipped the step of letting his mix cool down first and shoved it in still hot. He expected a melted mess. Instead, his came out frozen before his classmates, who'd followed the recipe and let theirs cool first. A visiting physicist heard his question and, instead of dismissing it, tested it. It held up. What almost nobody realized at the time is that this exact puzzle had already been noticed and dismissed for over 2,000 years. Aristotle wrote about it. So did Francis Bacon. So did Descartes. It took a teenager's stubborn question to finally get it taken seriously. So, what's actually going on? There are a few real candidates and no single agreed answer. Hot water evaporates faster, so there's simply less of it left to freeze. Hot water can develop stronger convection currents, circulating heat to the surface faster where it escapes. Heating water can drive out dissolved gas, and less dissolved gas may change how and when ice actually forms. And the cooler cup may be more prone to supercooling, dropping below freezing while still liquid, delaying the moment it visibly turns to ice. Every one of these effects is real on its own. None of them, alone, fully explains what's been measured. And when modern physicists tried to pin it down with tightly controlled experiments, the effect got slippery. Sometimes it showed up, sometimes it didn't on the exact same setup. Some researchers now argue there may not be one single Mpemba effect at all, just a tangle of small effects that occasionally line up. And in the last few years, an even stranger version of the same idea has shown up in an entirely different corner of physics. Physicists studying quantum systems have found cases where something further from equilibrium relaxes back to it faster than something already closer. They're calling it the quantum Mpemba effect. Same paradox, completely different scale. 2 cups of water in 1963 somehow led here. A kitchen mistake that shouldn't have mattered turned into a question physics still hasn't closed. This channel finds a puzzle just as stubborn every single day. Subscribe so you don't miss the next one.